last class. Okay, students, can you hear me?
Yes, sir.
Okay, so I think I have covered damped oscillation. I have covered the definition of damped oscillation. If I share my screen, then I think you will understand which portion I already covered. I already covered the equation of damped harmonic oscillation equation, and then I think I already discussed about the conditions of damped harmonic oscillations, and discuss more about case one, right? I think I have already covered the full things about case one, so I will start from case two in my today's class, right?
Yes, sir.
So if we go back, and you can see that our case one is if the omega naught square is greater than gamma square by 4, here gamma is a constant called damping constant, right? Gamma is equals to b by m, and so in our case 2 is called the critical damping condition, where omega naught squared is equals to gamma squared by 4. That means these two terms are equal, so this term will be omitted from our equation. So we can write down like that: p is equals to what? Minus gamma by 2 only in case of our second scenario. In the second scenario, we see that omega naught square is equals to what? Gamma square divided by 4, and we have the equation like only p will be minus gamma by 2 plus minus root over omega gamma square divided by 4 plus minus Okay. Rule number 73. Are you there? Please mute your microphone. Okay. Okay. So, but in case of our equation was like that. Our equation of uh, second order homogeneous equation was like d square x by dt squared.
Sir, pictureটা blur আসতেছে.
Yes, I think the picture is clear now. Okay.
Yes, sir.
Okay, our second order homogeneous equation was t square x by dt square plus gamma dx over dt plus omega naught squared x is equals to 0, as we already discussed a lot of things about this equation. So if we solve this equation, our solution will be like we assume that our solution will be like e of pt. In case of our second situation, p is only minus gamma by 2. So if we put this value, we can find out one of our solution. But this is a second order differential equation, so there will be two solutions. So if the one solution is like that, the another solution will be like t e of minus gamma by 2 into t. Here we need a constant here. Okay, you will discuss a lot of things about how you can solve this type of solution in case of second order differential homogeneous equation in your math course. So that is not considered things. In my case, I will just show you that one solution is like that, so there will be another solution, and we can assume that another solution will be like this fashion. So our total solution, we can write down our total solution like x is equals to what? A e of pt plus b t of e to the power pt. So we can write down a plus bt e of pt, and we know that in the second scenario we have the value of p is equals to minus gamma by 2 into t. So we can write down this equation like this fashion. Okay. Okay. Okay, after this, if we draw the graph of this pattern, as you see that our first term is only which graph? Only the exponential portion of the graph. If we increase the value of t here, our exponential graph will be like this fashion. If we increase the value of t, our exponential will drop sharply. Okay, and in our second portion we have another t terms e to the power minus gamma by 2 into t, so it will sharply decrease and will be zero soon. Okay, so in case of our second condition, our graph will be like this fashion. In the critical condition, we have only the exponential portion. There is no sine and cos term, so there will be no oscillatory part. In case of critical condition, there is only the exponential part in our equation, so the graph will be like this fashion. So in case of our second condition, that means omega naught square is equals to gamma square by 4, we can write down this. In case of this scenario, we can draw this figure from our solution. I think you understand. Anybody have any confusion about the critical damping? Okay. So if you have no question, then I will move forward, and our next target is to find out the solution in case of our third condition. Our third condition is omega naught square is less than gamma squared by 4. So in this scenario, we know that p is equals to like minus gamma by 2 plus minus root over gamma squared by 4 minus omega naught squared. Okay, so we can write down this equation like this fashion. Minus gamma by 2 plus minus, now here you see that this term is greater than this term, so there will be a positive value here, so we can found a number that is positive number. Let's assume this number is lambda. Okay, let's assume this positive number is lambda. This is a real positive number. Okay, so one of our solution in case of one of our solution will be like I can write down one of my solution, that means x1 will be like e of pt. So here one of the value of p is like e to the power minus gamma by 2 plus lambda into t, right? And our another solution will be like x2 e to the power pt, and we can write down this like e to the power minus gamma by 2 minus lambda into t, right? We can write down the total solution.
স্যার x2 তে কি লিখেছেন?
x2 is equals to that, where one solution is like the value of p, one value of p is like minus gamma by 2 plus lambda, and another will be like minus gamma by 2 minus lambda. So I put the another value, that means minus gamma by 2 minus lambda into t. Okay, so our total solution will be like, if we consider two constant here, the first solution e to the power minus gamma by 2 plus lambda into t, and another part is like b e to the power minus gamma by 2 minus lambda into t. Okay, so in this case you can see that there is only which part, only exponential part in our equation. And what is the difference between our previous solution? If I share my screen, in case of condition 2, you see that here is an extra t term is remaining here. So the gradual the rapid decrease of our graph. But in case of here, there is no extra t term is multiplied in any solution. So here is again the decreasing is there, but the uh, but this decrease is less than the critical condition. Okay, so because there
after the record হচ্ছে না স্যার, রেকর্ডিং অফ করা স্যার।
Okay, please remind this thing whenever I start my class. Okay,
Recording in progress.
Okay, so in case of condition 3, as you see in the slide, that you see in the slide, in case of condition 3, there is no t multiplied in the solution. So there will be only exponential part. If you increase the value of t, then e to the power, that means something, that means minus gamma by 2 plus lambda, where gamma by 2 is greater, so this term will be negative. So this term is negative. So if you increase the value of t, then exponential curve will decay down, and there is only the exponential term in two part of this equation. So our graph will be like this fashion. This will be decaying, but decaying more slowly than in case of critical condition, because in the critical condition equation we have another extra term 3. So if the value of t e to the power minus t, this value is more rapidly decreased than this term. Okay, let's consider two things. Okay, let's consider according to our two solution, this is in case of overdamping and this is in case of critical damping. Here you see that if you increase the value of t, there will be decrease in only the exponential part. If you increase the term t here, then this term will be really less than 1, and if you multiply it with by t, then this will be goes down rapidly. Okay, then this term. So as we see, if you put all these graph here, then you can understand we already discussed in case of oscillatory behavior in our previous class, and today we will saw that the critical damping condition, there is a t term and exponential part is multiplied there, so the damping is really rapid. But in case of over damping, there is only exponential part, there will be decreasing, but this decreasing is really less than in case of critical condition. So these are three graphs of damping oscillation, and you need to understand all the three curves deeply. Otherwise you cannot answer the question whatever I give you in exam. Okay, So I think you understand this part. Anybody have any question about this? Okay, okay. Then I will check you. Okay, rule number 47. Are you there? Rule number 47. MD Ashraful Hassan, are you there? Okay, note down rule number 47. Rule number 19. Roll number 019. Are you there?
Sir, present, sir.
Yes. Can you please explain this critical why this critical damping curve is like this and why the over damping curve is like this as you see in your screen? Can you
Yes, sir.
explain?
Sir, the critical damping curve is, sir, a bit more steeper than the over damping, sir. It is
Yes.
because there is an extra t in the equation, sir. A plus bt into e to the power something.
Yes,
So there is
exactly.
an extra t, so which makes the graph, the slope of the graph more steeper.
Okay. Very
And
nice.
in
So,
case of
so
over,
I understand. You understand that whole things are very good, very good. Okay,
thank you, sir.
I'm very happy about your explanation. I think you understand properly. Okay, so our next target is in case of LRC circuit. We will see how the damping conditions are proposed in reality. Okay, so this is an LR circuit, this is an inductor L, and this is resistance R, and this is a capacitor C. If we consider the voltage through the capacitor is VC, and here the voltage through the inductor is VL, and the voltage through the resistance is VR. So we can consider VR, VL, and VC. If the current of this circuit is I, so we can write down VR in terms of the voltage of the resistance. We can write down V is equals to what? I into R. In terms of capacitance, we also know this equation like V is equals to Q by C. And in case of inductor, we also know that the voltage is equals to what? L di by dt. So according to Kirchhoff's voltage law, we can write down this equation like the total voltage IR plus Q by C plus L di by dt is equals to 0, means there is any other source in this circuit, so there will be a 0 in the right side. I think you understand this equation. This is really easy. Okay, if you have question, then you can ask me. Okay, okay, so we can rewrite this whole equation like this fashion. Okay, that means we already have, if we divide this equation by L, then we can write down this equation like R by L di by dt 1 LC into I, and we can also write down this equation like here you see that what I is equals to what, if I write down in the board what we know that I is equals to what, dq by dt, right? So if I put the value of I in my equation, our equation will be like in the first term of the equation there is I into R, so we can write down this equation like R dq by dt. Then our second term will be like Q by C, and our third term will be like L di by dt. So we can write down this equation like d square Q by dt square equal to 0. After that, if we divide this equation by L, then here is an L and this is another L. So we can also see that this is also an what? This is the equation of what? Can anybody tell me? Can anybody tell me? This is the equation of second order differential homogeneous equation. That means d square q by dt squared plus r by l dq by dt plus q by lc. Okay.
Okay, sir.
Okay, so if I move forward, then our next thing is if we compare this equation by our damping equation, like what is our damping equation? D square x by dt squared plus gamma into dx by dt plus omega naught squared into x equal to 0. If we consider this term, if I write down our this equation, consider this term our dx by dt, this is the equation of x and this is the equation of q. So the multiplied term with the dx by dt is gamma, so here dq by dt is r by l. So we can write down our gamma is equals to what? R by l. And here is another term, the constant term, that means omega naught square x. That means we can write down this part like what? Q by lc, right? I think you understand. Here q is the x, so omega naught square will be 1 by lc. You understand, or I need to explain it again? Okay. Okay, if I write down this equation in this fashion, that means d square q by dt squared plus r by l dq by dt plus q by lc. Here this is q. So according to this equation, we can write down gamma is equals to what? R by l, and omega naught square is equals to what? 1 by lc. I think now everybody understand this analogy about this is the damping constant in case of LRC circuit, and this is the angular frequency in case of our LRC circuit. Okay.
Okay, sir.
Okay, then according to this solution, according to this solution have three cases. We already considered one. Case number one is oscillatory. Case number two is what? Critical. Case number three is overdamping condition. So these two equations are pretty similar. So this equation have three conditions. The solution have three conditions like oscillatory behavior, critical damping, and over damping. And we know that if omega naught square greater than what? Gamma square by 4, then this is called the oscillatory behavior. Our omega is like root over lc, so we can write down 1 by lc greater than r square divided by 4l square is the condition of oscillatory behavior in case of LRC circuit.
Yes.
If we write down this is equals, then this will be our which condition? What is the name of this condition?
Critical one.
This is critical condition. And if we write down this equation like this fashion, then our equation will be like overdamping condition. These are three solutions as we already discussed in my previous class and today's class. Okay, so if I move forward, in case of case one, we already discussed that in case of damping harmonic oscillation, but for LRC circuit, our case one is like 1 by LC greater than like R square divided by 4 square. So our solution will be like in the case one. What is our solution? Can anybody remember what is the solution in the case one? If I share my screen, you can see that our solution was x of t is equals to what? a e to the power minus gamma t by 2 cos omega 1 t plus phi, as we already discussed it in my previous class. So we know that the solution of damping oscillation in case of omega naught square greater than gamma square by 4, our solution was like this fashion. So in case of LRC circuit, we can write down our solution in case of case 1, that means Q of t a e to the power minus, what is our gamma? The value of our gamma is r by l. So if we put the value of gamma by 2, that means r by 12 into t cos omega 1 t plus 5. I think you understand the solution of our differential equation in case of LRC circuit. বুঝতে পারছেন সবাই?
Yes, sir.
Okay. So what is the value of omega 1? If we move back, what is the value of our omega 1 in case of our solution? Omega 1 square means omega naught square minus gamma square by 4. So we know that in case of LRC circuit, we have a specific value of omega and we have a specific value of gamma, right? As you see in the slide, we have specific value of gamma, that means R by L. If we have an LRC circuit, we know that the value of L is what and the value of R is what. So we can find out the value of gamma in case of LRC circuit, and we can also find out the value of omega naught if we know that the value of L and C. So if we put it in omega 1, then we can write down this equation like omega 1 is equals to what? Root over like what? Gamma square minus r square by 4. Okay, so this is our angular frequency. So if we write down the equation of frequency, we know that what omega is equals to twice pi f. So f will be like twice pi by omega. So we can write down this equation like f is equals to what? 1 by twice pi, and this is our value of omega. Okay. Okay, I think you understand. Anybody have any question about this? Do you understand in the case 1? When you use LRC circuit, I think you understand, but I need to check you. Roll number 30.
ওমেগা 1 এর ভ্যালু বের করাটা একটু আরেকবার বলুন।
প্লিজ কোন পার্টটা আবার রিপিট করতে হবে?
ওমেগা 1 এর ভ্যালু যেটা ইকুয়েশন যেটা বের করলেন।
Okay. If we move back, our previous class was this is the value of we let in our previous class that omega 1 square means omega naught square minus gamma square by 4, right? If you understand my previous class, then you know this, the value of omega 1 square means omega naught square minus gamma square by 4. In today, we in case of LRC circuit, there is some specific value of omega, a specific value of gamma. And what is our value of omega and gamma? As we already discussed, that the gamma is R by L and omega naught is equals to root over 1 by LC. So if you put the value in omega 1, that means what? Omega naught square minus gamma square R by 4, then you can find out this value of omega 1. I think you understand still?
Yes, sir. Yes, sir.
Okay.
Clear.
Okay. Rule number 30. Are you there?
Yes, sir.
Rule number 30. 30. Rule number 30. Are you there? Okay. Rule number 74. Are you there? Rule number 74. I don't understand why you are not responding.
Present here.
Okay, okay, rule number 30. Okay, then please can you explain why I write down the solution of differential equation in the case one is like this fashion, that means a e to the power minus r by 12 into t into cos omega 1 t plus phi. Can you explain this? Rule number 30, can you explain?
Sir, sorry, sir, I can't.
If you can't, then you don't understand, and then why you were not responding? Please, if you don't understand any topic about the today's class, you can ask me, because if you feel shy, then it is not good for you. Okay, you cannot get good marks in the exam if you feel shy in the class, and if you have question and if you don't ask me. Okay, so I think rule number 30, you are present in my previous class, and in my previous class we already discussed about in case of one, that means our oscillatory solution, that means omega naught square greater than gamma square by 4, we will already solve in case of this, so that our solution, we can write down our solution like this fashion, that means a e to the power minus gamma t by 2 cos omega 1 t. And in case of LRC circuit, we have a specific value of gamma and omega 1. So if we put the value of gamma and omega 1 in terms of our LRC circuit, that means this is gamma and this is omega 1. This is the equation of omega 1. So we can write down our solution of second order homogeneous differential equation of LRC circuit. Solution is like this fashion. I think now you understand the rule number 30.
Yes, sir.
Okay.
The question, sir.
Yes, you can ask.
So this e to the power minus gamma by 2 into t, this is called a damping factor. What is the
Yes.
significance of this damping factor? What does it mean?
Okay. Without this damping factor, in case of our simple harmonic motion, what is the equation? Like t square x by dt squared plus omega naught square x is equals to 0, and the solution was like x is equals to a cos omega t plus delta, right? And our graph was like this fashion. Okay, so there was no damping. The amplitude is still remaining constant throughout the time frame. Okay.
Yes, sir.
Okay. Now consider in case of our damping, our equation was a bit changed. In our equation, we see that there is an extra term, that means gamma dx by dt plus omega naught square x equals to 0. And if we solve this equation, we already see that in case of one, our solution was like x is equals to a e to the power minus gamma by 2 into t cos omega 1 t plus delta. So there is a cos term. If you draw the cos graph like this fashion, but there is a multiplied exponential graph here, and we know that the exponential curve is like this fashion. If you increase the value of t, the graph will be decreased soon. So if you multiply both this together, then you will find that our amplitude will decrease with time, and this is called our oscillatory behavior. Okay, I think you now understand what is the difference between damping oscillation and simple harmonic motion.
Yes,
okay,
sir.
this is actually the damping part. For this, the value of our amplitude is decreasing with time. Okay, I will discover the case one again. Here you see that in case of our solution like this fashion omega naught square gamma square by 4, we find our solution like this fashion, like this: x is equals to a e to the power minus gamma by 2 into t cos omega 1t plus delta. So if I omit this part from my board and if I draw, let's consider only cos part. Okay, so what is the graph of cos? Like this is the graph of cos, right? And what is the graph of exponential graph? We know that exponential, if t is equals to 0, that means if we put the value of t is equals to 0, that means e to the power 0 is equals to what? Something to the power 0 is equals to what? That means this value, if you put the value of t increase, then you will find the graph will be like this fashion. If you multiply both together, then you will find the graph like this fashion. Okay, so if you multiply both these graph, you will find this graph will be like oscillatory, but decreasing its amplitude with time. Okay.
Okay, sir, clear.
Okay, I think you understand. Anybody have any other question about this free condition? Because this free condition is really important, and this damping oscillation is really new things because this is not included in your HSC syllabus. So you need to understand this type of things because you are the student of computer science and engineering, and the computer science to understand computing part, you need to understand this type of things because this is really important. And in my today's class, we also discussed about some more thing about this because this is really important part. I told you again, this is really important part. In your lab, you need to use oscilloscope. In the oscilloscope, you need to understand the solution, you need to understand the frequency, as I already find out. All these things you need to find out from the oscilloscope. In the oscilloscope, you need to measure this voltage in your lab, so you need to understand this theory. Okay, so if we move forward, our next topic is to the harmonic motion combination at right angle. Now if I share my screen and if I omit the full part from my board, then আমরা এতদিন যে কাজগুলো করেছি, লাইক আমাদের এখানে একটা ওয়েভ ছিল, and আমাদের এই যদি আরো একটা ওয়েভ থাকে like this fashion, if we sum these two wave, we will find this wave if the value of this value 1, this value 2, if we sum it, then we will find 2, then our amplitude will be like 2. Okay, so we will consider this type of superposition till now. Okay, now consider that one wave is in x direction and other wave is in y direction, then what will happen?
I have a question about elastic circuit.
Okay, you can ask.
What about the case 2 and case 3 about elastic circuits?
Okay, what about if you find the thing about case 2 and case 3? We already discussed more thing about case 2 and case 3 in case of damping oscillation. You already have the value of gamma in case of LRC circuit.
Yes, sir.
So you can put the value of gamma here, so you can find out the solution in case 2. And in case 3, you already have the value of gamma. If you put there, and the lambda value is like what? Lambda value is like gamma square by 4 minus omega naught square. In case of LRC circuit, you have specific value of omega naught and you have specific value of gamma. So by using this, you can also find out lambda. So if you put all this value here, you will find the solution in case of over damping. I think you understand. This is your HW actually. I can. Okay. এই টাইপের জিনিস কিন্তু তোমাদের এক্সামে আসবে। লাইক আমি কেস 1 করিয়েছি এবং আমি অলরেডি ডিসকাস করেছি অ্যাবাউট কেস 2 and case 3, what is case 2 and case 3 about damping oscillation. So if you really understand the part, so you can understand what is the solution will be in case of LRC for case 2 and case 3. So I think you can do this at your own. So now go back to the board again. If you have one waves in x direction and another wave in y direction, what will be our superposition? Okay, so let's consider this. You have a graph. Let's consider the cos graph. So we need to start from here. So what will be the equation of this? X is equals to what? A cos omega t, right? And if you have another curve like this fashion, that means y direction, so you can write down this like a, this is 1, this is 2 cos omega t plus delta. Let's put here the delta is the phase difference between two things. Okay, one is in which direction? X direction, and another is in which direction? Y direction. Let's if we put these two things, what will be our superposition value? Can anybody? At first, you consider that there is no phase difference between these two part of the wave. Omega naught, this is omega naught. So we can consider this x is equals to a1 cos omega naught t and y is equals to a2 cos omega naught t. So from these two equations, we can write down like what? We can write down like x by a1 is equals to what? Y by a2, right? From this, we can write down y is equals to what? A2 by a1 into x, right?
Yes, sir.
I think you understand. A2 by a1 into x. So what is the, this is the graph of like y is equals to mx. So if we draw the graph of this equation, we will find the graph something like this fashion. Okay, this is the graph of what? If this is x and this is y axis, we can find out this graph like y is equals to mx like this fashion. So if we superimpose these two graphs, we will find the graph something like this fashion. Okay, I think you understand my point. Anybody have any question about this? Okay, so if I share my screen, that combination at right angle, as I mentioned already, what is the right angle? Right angle means a 90-degree angle. Our one wave is in x direction and another wave is one direction. So the angle between them is what? Angle between them is a 90-degree. That means the right angle. So let's consider the case that means the phase difference is 0. Then our graph will be like a rectilinear motion. That means we will find some straight line of the graph as in case of 0, if our phase difference is 0. If this phase difference is not 0, if this phase difference is pi by 2 here, then we can write down our equation y is equals to a2 cos omega t plus pi by 2, and we can write down this like minus a2 sine omega naught t. And by using these two equation, x is like equation of cos and y is equation of sine. If we squared both equation and we add together these two equation, we will find the equation like this fashion. And this is the graph of what? This is the graph of elliptical equation, right?
Yes, sir.
I think you understand. Anybody have any question about this elliptical equation? How can we find this elliptical equation? Okay, if you understand, then I will ask somebody to. Okay, roll number. Okay, so roll number 97. Are you there?
Yes, sir.
Okay, can you explain how can we find this equation in case 2, that means phi is equals to pi by 2? What is phi? What is defined by phi?
Phi means surface.
Yes, phi means the phase difference of x and y. Okay, if the phase difference is pi by 2, then we can write down our both equation like this fashion. After this, how can we write down like x by a1 square plus y square by a2 square is equals to 1?
Surface.
So if you don't understand, why not you ask me question? Okay, student, I repeat again and again. If you don't understand, please do not hesitate to ask a question. Okay, our value of x is equals to, in case of phi is equals to what, pi by 2. Our value of x is equals to what, a1 cos omega naught t, and our value of y is equals to a2 minus a2 sine omega naught t. So if we square down both equation, like x square is equals to a1 square cos square omega naught t, and square down this equation like y square a2 square sine square omega naught t. So we can, if we add these two equation, if we write down our first equation like x by a1 square is equals to cos square omega naught t, and we can write down our second equation like y by a2 square sine square omega naught t. If we add these two equations, we can write down this like x square by a1 square plus y square by a2 square, and our right side will be cos square theta plus sine square theta, and cos square theta plus sine square theta is equals to what? 1.
sir.
So this is, yes, this is square, this is square. Okay, okay, I think you understand why, how can we write down this equation like this fashion. This is the equation of ellipse, but now let's consider that a1 and a2 is equal. So what will be if the a1 and a2 if you let the a1 and
I have a question,
a2,
sir.
yes, you can ask.
Sir, here it is written elliptical path in clockwise direction. Why, sir, clockwise?
Yes, in your HSC syllabus, there is something missing there. If there is a +1 in the right side, then this is the path of clockwise direction rotation, and if there is a minus sign is present here, then this is anti-clockwise rotation. Okay. This is the part that is missing in your HSC syllabus. Okay.
স্যার এখানে ওই 1 এর জায়গায় -1 এর কথা বলছেন?
Yes, যদি এখানে 1 এর জায়গায় -1 থাকতো, তাহলে আমাদের পাথ ডিরেকশনটা জাস্ট ইকুয়েশনটা সেম থাকতো, জাস্ট আমাদের পাথ ডিরেকশনটা ক্লকওয়াইজ এর জায়গায় অ্যান্টি ক্লকওয়াইজ হয়ে যেত। এন্ড I will show that এটা কিভাবে ক্লকওয়াইজ এন্ড অ্যান্টি ক্লকওয়াইজ হয়ে যায়। আমি জাস্ট যখন একটু মুভ ফরওয়ার্ড করব, একটু সামনের দিকে যাব যখন এই লেকচারটা, then you will understand the whole things. Okay.
আচ্ছা।
Okay, now let's consider that the a1 and a2 is equal to a, then you can put the value of a square y square is equals to 1, then you can write down this equation like a square, and what is this is the equation of what?
Circle.
This is the equation of circle. So if you combine the two wave, that is one in x direction and one is y direction, if their amplitudes are same and if their phase difference are pi by 2, then we will find the equation of what? We will find the equation of a circle, and the radius of the circle is a. Okay. So I think today we'll okay, let's cover another part. So, okay, let's now consider that the phase difference is pi. So if you put the value of pi here, you will find that -a2 cos omega naught t. Again, you will see that x is equals to a1 cos omega naught t and y is equals to minus a2 cos omega naught t. If you put the value x by a1 is equals to cos omega t, and you will find y by minus a2 will be like cos omega t. So you can write down this equation like y is equals to minus a2 by a1 into x. Let's consider our first case, y equal to a2 by a1 into x. That means এটা যেই ডিরেকশনে থাকবে, কেস 1টা যেই ডিরেকশনে থাকবে, আমাদের কেস 3টা কি থাকবে? Opposite থাকবে, because there is the minus sign. And here you see that this is positive slope. Okay, this is positive slope, that y is equals to mx. That means this is positive slope, but here you see that this is negative slope. So I think everybody of you now understand what is the meaning of positive slope and negative slope. The graph of positive slope is something like this, and the graph of negative slope is something like this, right?
Yes, sir.
Okay, so I think you understand how these all things are changed with this phase. Okay, so if you consider this like 3 pi by 2, then if you put the value here, then you will find this is a cos graph of x and this is the sine graph of y. So if you consider in case of our like case 2, the similarly, then you will find the equation, but you will find the minus 1 here. That means this is the anti-clockwise direction. Okay,
স্যার মাইনাস ওয়ানটা কিভাবে আসলো স্যার?
okay, then I will move back and I will consider this case like our x is equals to what? a1 cos omega naught t, and if we square this graph, like x square will be like a1 square cos squared omega naught t. So we can find x square by a1 square will be like cos square omega naught t. Okay, so similarly we can find out y squared like a2 squared. Okay, y square a2 square is equals to what? We can find out this value like okay, sine squared omega naught t. Let's consider here another case like 3 pi by 2 means what? 3 pi by 2 means what? This is the value of okay, now consider this, there is a minus 1 here, but there will be a plus 1 like here, according to our case of okay, the case 2 and case 4 will be the same case. Okay, there is a mistake here, is minus 1. Okay, this will be like plus 1. Okay,
ওকে স্যার।
okay, there is a mistake in case 4 in my slide. This there is a minus 1 here, but this will be like plus 1. Okay, but in case of, because you see that if you add together like cos square omega naught t plus sine square omega naught t will be plus 1 again, so you will find a plus 1 here again. So in case of pi by 4, there will be graph like that, but we cannot, this is harder to see, we cannot আমরা এই ইকুয়েশন গুলোর মতো এটাকে ডিরাইভ করতে পারি না। সো আমাদের গ্রাফিক্যাল অ্যাপ্রোচটা ইম্পর্টেন্ট, বাট আমরা আজকের ক্লাসে আর মুভ ফরওয়ার্ড করব না, আমরা কেস 4 পর্যন্ত just consider করলাম আজকের ক্লাসে, and then in the next class we will move forward and discuss more about case 5, case 6, and discuss more about all the graph which is already in my slide, but we are running out of today's class time. So I think you understand whatever which portion I already covered in my today's class. Anybody have any question about today's class?
স্যার আপনি আমাদেরকে কোনো মানে ওয়েবিং দিতে পারবেন যেখানে আমরা এই কোয়েশ্চেন গুলো সিমুলেট করতে পারবো?
If you want to simulate this type of equation, like as I already mentioned that in your lab you have to use your oscilloscope. In the oscilloscope you can see that If you give a wave in the x direction, you can see in the oscilloscope screen, you give a wave in the x direction and you give another wave in y direction, then you can see that the graph will be like this fashion in the oscilloscope screen. If you put the value, you can change the value of this phase difference there. If you put the value of phase difference 0, you will find the graph like something like this fashion. And if you put all the values like delta is like this, then you can find out this graph look like this fashion. So whenever you getting chance to go to MIST in your lab, then you can look after all these things in your own eyes.
Yes,
Okay, so I need
স্যার
to
রোল
go
কল করবেন?
yes, I need to go to MChem. Okay, please wait. আচ্ছা, আপনাদের কি আর কোনো ক্লাস আছে পরে? I think no.
না স্যার, আর নেই স্যার।
So please give me a moment for. Okay, now I will share my screen. I think you know, see the attendance slide, the class attendance entry, and you are the student of CSC. This is spring, and this is physics 101 section A. I'm going to give attendance section A. Okay, this is the class time of what? 1:45 to 2:40, right?
Yes, sir.
Roll number 2019 batch, roll number 86. Absent. 2019 batch, roll number 29. Absent. 2021 batch, roll number 2. Absent. Roll number 4. Absent. Roll number 6.
Yes, sir.
8.
Yes, sir.
10.
Yes, sir.
12.
Present, sir.
Absent. Roll number 12.
Present, sir.
Okay, roll number 14. Roll number 14 absent. Roll number 16.
Yes, sir.
18. Roll number 18 absent. 20.
Present, sir.
24.
Yes, sir.
26.
Present, sir.
28.
Present, sir.
30.
Present, sir.
32. Roll number 32
Recording stopped.
absent. Roll number 34.
Present, sir.
36.
Yes, sir.
38.
Present, sir.
40.